Okay, welcome back. So today we're going to talk about graphing rational functions. Okay, so these are going to be 7 steps. I'm going to explain each one, so make sure you take notes because I'm going to go into a little bit more detail on some of these steps than what's on the board. Okay, so here for graphing rational functions, again, we're assuming that we have a rational function in lowest terms. Okay, so if we have a rational function where it's in lowest terms, then to sketch the graph of such a function, we would follow these 7 steps. So step 1, we're going to find any vertical asymptotes. Step 2, find any horizontal or oblique asymptotes. Okay, we're going to want to find what those are, if there are any. And then step 3, if the bottom is not 0 when we plug in 0. Okay, so in other words, if q of 0 is not 0, in other words, if we don't get 0 in the denominator when we plug in 0 for x, then what we want to do is we want to go ahead and find f of 0. Okay, so in other words, we want to find the y-intercept. Okay, obviously if we plug in 0 here and we get 0 in the denominator, then there is no y-intercept. Okay. But if there's a y-intercept, we want to find it and we want to be able to plot it, and we do that by evaluating f of 0. Okay. Step 4, plot the x-intercepts if they exist. Okay, and so that goes by solving f of x equal to 0. So we set the function equal to 0 to find the x-intercepts. But with rational functions, it's actually the same as just finding the zeros of the numerator. Okay, so we can just set the numerator equal to 0, and that will also tell us the x-intercepts. Okay, so again, so find x-intercepts. So again, just to recap the first 4, we want to find, we want to find any vertical asymptotes, find any horizontal or oblique asymptotes, find any, if there's a y-intercept, we want to plot the y-intercept, and we want to find any x-intercepts. And if they exist, we want to plot those as well. And then step 5 is we want to determine whether the graph is going to intersect any non-vertical asymptotes. What does that mean? Well, it means that a graph will never cross a vertical asymptote, but it may cross a non-vertical asymptote. So for example, if I have a graph that, let's say, has a horizontal asymptote, let's say it does this, right? Now, it may not cross on one end, but it may cross on the other end. Okay? So, non-vertical asymptotes may be crossed. Okay, so we have to determine whether the graph crosses one way or the other. The way we do that is we would take f of x. So let's say if we have a horizontal asymptote, we would take f of x. And let's say the horizontal asymptote is located at y equals b. Then the way we determine whether it crosses or not is real simple. Just set it equal to that value. Set f of x equal to b and solve it. If we can solve it, then that means it does cross. And we can find out where it crosses. Okay, and we want to plot that point. Okay, or if it's an oblique asymptote, right? So what if it's an oblique asymptote? Then you're going to get something that might look something like this, where your oblique asymptote might look like that, and you might have something that looks like that. So if you want to determine whether the graph crosses an oblique asymptote, and let's say this is y equals x, right? Then what you would do, or even x plus 1, what you would do is you would set the function f of x equal to the oblique asymptote, which would be, in this case, x plus 1. And then so you would solve this for x, and if you were able to get a solution, then it does cross, right? And if it doesn't, if you can't solve it, then it doesn't cross. Okay? And so that's how you would do step number 5. Okay? Then step number 6 is you plot the selected points as necessary, and you want to choose an x value from each of the domain intervals, because the asymptotes are going to cut the domain into intervals. And so what you want to do is you want to pick a point in each one of the intervals to plot to help you determine what's going on in that interval of the graph. Okay? And then step number 7 is once you have all of that plotted and you have all of the intercepts plotted and everything, the horizontal asymptotes, then you just complete the sketch by just connecting the dots with a nice curve like we've been doing. Okay? And so these are the steps for graphing a rational function. And so what I'm going to do is I'm going to do some examples in the next video or two of how we would go through these steps to graph particular problems. Okay? That's it. Have a great day.